Hello, everyone. In this lesson, we will learn about the components and classifications of fire water supply systems. First, let's discuss the components of a fire water supply system. The fire water supply system is composed of intake pipes, water supply pipelines, water supply accessories, water supply equipment, water distribution facilities, and metering instruments. 1. Intake pipes. Intake pipes refer to the pipe sections that lead from the connection point of the external water supply network into the building. They are the main inlet pipes connected to the external water supply network, also known as entry pipes or household pipes. Intake pipes are generally buried underground, crossing through the external walls or foundations of buildings. Affected by ground loads and freezing lines, they are usually buried more than 0.7 meters below the outdoor ground level. Once the intake pipes enter the building, they immediately rise to the depth where the water supply mains are buried to avoid additional excavation. The water supply mains are generally located 0.3 to 0.5 meters below the indoor ground level. For most buildings, only one intake pipe is needed, entering from the middle of the building. For buildings that require uninterrupted water supply, there must be at least 2 intake pipes, which should be introduced from different sections of the external ring network. 2 inlet pipes are installed, each led into the building from opposite sides to ensure a safe water supply, as shown in the diagram. When one pipe is out of order and needs maintenance, the other pipe can still guarantee the water supply. When it is necessary to introduce from the same side, the distance between the 2 inlet pipes must not be less than 15 meters, and a valve must be installed on the outdoor water supply pipe between the 2 inlet pipes, as shown in the diagram. 2. Water supply pipelines. Water supply pipelines generally form a network within buildings, including main pipelines, riser pipes, branch pipes, and sub-branch pipes, which are used to transport and distribute water to various points of use inside the building, as shown in the diagram. Main pipelines, also known as main ducts. They transport water from intake pipes to different areas of the building. Riser pipes, also known as standpipes. They transport water from main pipelines vertically to different floors and heights within the building. Branch pipes, also known as distribution pipes. They transport water from riser pipes to the pipes within each room. Branch connection pipes, also known as distribution branch pipes. They transport water from branch pipes to the pipes at each water-using device. For each riser pipe, a valve is generally installed on the first floor after leading out from the main pipe, so that maintenance within the water supply range of that riser pipe does not affect the normal water supply of other riser pipes. 3. Water supply accessories. Water supply accessories refer to various types of valves and equipment in the pipeline system that regulate water volume and pressure, control the direction of water flow, improve water quality, and facilitate the shutoff of water flow for maintenance of pipelines, instruments, and equipment. Commonly used valves include gate valves. Provide a tight closure but with high water flow resistance, suitable for pipelines with a diameter of no more than 50 millimeters. They only allow unidirectional flow of the medium and have directionality during installation. Sluice valves. Have a low resistance to water flow, used for pipes with a diameter greater than 50 millimeters, susceptible to wear and leakage if impurities fall into the valve seat. Non-directional. Divided into rising stem sluice valves and non-rising stem sluice valves. Butterfly valves. Butterfly valves feature a small operating torque, are easy to open and close, and have a compact structure and small size. The valve plates can regulate, throttle, and shut off within a 90-degree flip range. Where a butterfly valve can be used, try not to use a sluice valve, as it is more economical and has better adjustability. Check valves. Used to prevent the reverse flow of water in pipelines. Level control valves. used to control the water level in water storage equipment such as water tanks and pools to avoid overflow. Take a float valve as an example. When the water level rises, the float rises and closes the inlet, and when the water level falls, the float drops and opens the inlet. However, the float is large in volume, and the valve core is prone to getting stuck, causing overflow. Hydraulic level control valves. When the water level drops, the float in the valve descends, reducing the pressure in the pipeline and opening the sealing surface of the valve, causing water to spray out from both sides of the valve. As the water level rises, the float ascends, pushing the piston upward, which closes the valve and stops the inflow of water. This represents an upgrade from the traditional float valve. Safety valves. Safety valves are installed to prevent overpressure damage to pipeline networks, appliances, or sealed water tanks. There are generally two types, spring-loaded and lever-operated. Pressure-reducing valves. Reduce the inlet pressure to a required outlet pressure by adjustments and rely on the energy of the medium itself to automatically maintain a stable outlet pressure. 4. Water supply equipment. Include water pumps, pools, tanks, suction wells, pneumatic water supply equipment, etc. 5. Water distribution facilities. Water distribution facilities are the end-use points in the building's domestic, production, and fire water supply system networks. The water distribution facilities for fire water supply systems include indoor fire hydrants, fire monitors, fire hose reels, and various sprinkler heads of automatic sprinkler systems. 6. Metering instruments. Include water meters, flow meters, and pressure gauges. In addition to intake pipes, water meters should also be installed on the distribution pipes of certain parts and equipment where metering is required. A water meter should be installed on the water supply intake pipe to measure the total water usage of the building. To facilitate the repair and disassembly of water meters, as well as reading convenience, a fire meter pit is needed. The water meter and corresponding accessories are all set within the fire meter pit. Fire water supply systems are divided into fire hydrant water supply systems, automatic sprinkler systems, drencher systems, water spray extinguishing systems, automatic monitor systems, etc. The selection of a fire protection system should be based on the requirements for water quality, quantity, and pressure for domestic, production, and firefighting uses, determined through economic and technical comparisons. Generally speaking, except for fire hydrant systems and simple automatic sprinkler systems, other fire water supply systems should be independent and separate from domestic and production uses. In this lesson, we learned about the components and classifications of fire water supply systems. In the next lesson, we'll explore the commonly used materials for fire water supply pipes.